or who just joined.
Hello everyone. Hello Shri. Hello Arka.
So she is Akra from the side.
Yes.
Okay.
Yeah, hi Srinivas. Good evening.
Very good evening.
No.
So I'll take care, Shashi. Okay.
Thank you, sir.
Yeah. You can disconnect. I'll take care of it.
Okay.
Yeah. Thank you. Naveen, Kirti, Harsha.
Hello, sir.
Hope you're doing good. And Suhasini, uh, thanks for joining. And I'm just waiting for a few more people to join. We'll start. Okay.
Okay.
Yeah. So just to give a high level overview. So we had some discussions. Uh, Already some demos happened, but today anyway I'm going to start from the first class itself again, because we did it high level, but we start with some introduction once again, and we'll move forward on understanding on in deep architecture of Snowflake. Okay. Okay. Anyway, we'll start. Just to give a high level overview. So today's class, I am planning to give a introduction about Snowflake once again. I hope some people already mm, like gone through some previous demos also, but however, let us go once again. So let me share my screen. Hope you're able to see my screen.
Yes, Srinivas.
Okay. So we know that there are so many databases available in the market, but all these databases which are available, they are traditional databases which are in the on-premise physical server, and some databases are SQL databases, some databases are NoSQL databases also in the market now, and both are very popular And coming to like data warehouse. Whenever I say data warehouse, a data warehouse is traditional data warehouse which we usually see in the market is it will mainly store the historical data. When you go and see in the early 90s, most of the companies were very busy in storing the data in the traditional databases such as Oracle SQL Server and other RDBMS databases like Sybase, PostgreSQL, MySQL. These databases were very famous, and every company was planning to centralize their company's enterprise level data into these databases to use that for data for their application development. This was happening from 90s to 2000 decade extensively by every company. And when every company got success in centralizing the data and started using for their application development, after the successful deployment of application, the companies also started thinking on about analyzing the data also. So here analyzing means how to go and look like use the existing enterprise level data and how to use that data for their dashboard development and perform some kind of statistical analysis and business analysis, where every company started experiencing some challenges with real-time data to implement this, because the real-time data will never be same, it will be keep on changing, so my analysis never will go in the right direction. So the main reason why companies started leveraging the enterprise data warehouse or conventional data warehouse is because they want to separate the real-time data into another database and store the data which is historical data, the past data, and use that for the analysis. So that is where the birth of data conventional data warehouse has been started. In early 2000s, every company started centralizing their data into this particular conventional data warehouses, and a conventional data warehouse again is a database only, but which will have only historical data, not the current data. And every company started using all the existing RDBMS like Oracle SQL Server and other RDBMS also were very famous, and some part of CSV files also were people using for storing for using as a source. And the tools which are famous for building this data warehouse or conventional data warehouse are Informatica is one of the very popular tool, and the data stage, Ab initio, SSIS, SQL Server Integration Services, all these are very, very popular to build this enterprise level data warehouses. And also after this particular data has been centralized in a conventional data warehouse, people also started building the reports. Like for example, dashboards. Every company's management will be interested in these reports to understand their business. What are the company's sales compared to last month and current month? They want to compare. Want to build a dashboard with the particular sales for sales trend of last month and current month. So they will see what action to be taken after. They will see whether there is an increase or reduction in the sales compared to last month to current month. So these reports started giving some insights to the management to take some decisions also. And the structure of the data for this data is basically for building these dashboards or building this conventional data warehouse was only relational data. So here relational data means what? Rows and columns, database tables majorly. So people were not even using any semi-structured or unstructured data in this time period, because there was no any semi-structured or unstructured data was present during this time. Even people were not even considering that even it is present. Only the conventional data warehouse was people used to build using the traditional RDBMS which is in the structured form. And which were the famous tools during this time period? Oracle SQL, PLSQL, and SQL Server TSQL was very famous to build these data warehouses with the SQL kind of language, structured query language. People who know this SQL and PLSQL and TSQL, they used to have huge demand the market along with one ETL tool. And data loading frequency. When I talk about data loading frequency here, every company started building this conversion data warehouse by refreshing the data warehouse with the real-time database in the production. But when you are loading the data cannot be directly loaded from the real-time environment. So they need to wait for the real-time data to be ready by the end of business day, and then people started running some batch jobs to load this conversion data warehouse from the production real-time database. So this was every company used to follow to refresh the enterprise level data warehouses from the existing traditional RDBMS databases. And as soon as this particular conversion data warehouse is ready, every company started building their own dashboards, like revenue leakage, like analysis, and customers who are ready to switch, they want to identify them and they want to go and prevent them. So they used to build some reports on the potential customers churning. So these kind of applications or products people used to build on the historical data which is in the conventional data warehouse. This is about early 2000. As soon as we moved to like early 2010, there was a big revolution in the data. Suddenly data growth was suddenly increased, and within a span of 2 years, we experienced the data in the form of petabytes, and most of the companies started experiencing the huge amount of data, that too in the span of 2 years, especially. I hope someone already know about why there was a high data growth in the early 2010. Who will answer that? Anyone? What was the reason for high data growth suddenly after 2010? Anybody know that?
Social media
Ah,
account.
oh, very good, correct. So social media. So social media, when Facebook started their services in 2007 or 8, suddenly the companies started experiencing huge amount of data growth because everybody started loading their particular videos, images, documents, everything into the like a Facebook with their mobile applications, and Twitter, Instagram, and also we got like YouTube, WhatsApp. Every social media has been started generating this data, and suddenly data growth has been increased. When everybody will start uploading videos, images, and unstructured data more. Since we know that unstructured data is nothing but videos, images, documents, and also some part of like voice. This kind of data will be huge amount of data, which will in general will go and cast unstructured form and semi-structured form and also quasi-structured form also. So these are the other types of data which companies start experiencing. So they're unable to store them in the conventional data warehouse or database. So they started using the big data tools such as Hadoop. HDFS and MapReduce both were very popular, and people started using them. And MapReduce is used for distributed processing, and HDFS for storing the data. These two frameworks became very popular, and the MapReduce was processing huge amount of data, but however, it was a little bit time consuming when you are processing, and people start experiencing some latency. So Spark has been came into picture and slowly replaced MapReduce with the Spark. But coming to like BI tools, whoever wants to go and build a dashboard or business intelligence report on big data, the existing tools were not sufficient. So Power BI came to the market from Microsoft, and MicroStrategy also got some big data features as well. So these particular tools also got invented keeping big data in mind, and sources of this particular big data also companies' internal products and the CRM applications plus social media. Social media came into the picture only after big data came into the picture in the sources list. So some companies do some kind of real-time sentiment analysis. So they will try to understand customers' behavior and customer mindset to see whether the customer, whatever they tweet in the Twitter, is a positive tweet or negative tweet or it is a neutral tweet. They will even do that analysis also. So to build such kind of applications, I definitely need to capture the real-time data, which is, for example, Twitter tweets. I need that. And knowledge required for this particular big data environment also, Java is important that time. And since MapReduce got demised, slowly became obsolete, Spark with Scala came to the market. And after some time, Spark with Python also now very popular now, PySpark. Slowly, big data projects are started leveraging PySpark with big data. MapReduce and Scala both are slowly becoming obsolete now. They are getting disappeared. And data loading frequency here. For example, if you see in the traditional data warehouse, we are having only batch data loading. Only after business hours, whenever the applications are capture the daily transactions, that particular transactions will try to collect after the business hours, and then we'll try to load them into the data warehouse, big data warehouse, and that is what people are following. But both are batch and live. So live streaming data also became very popular after big data. Kafka is one of the framework which is helping. And as soon as this particular batch and live data has been people started capturing, they started building the real-time applications also. Like for example, credit card fraud detection, money laundering detection, recommendation engines. So everybody here may have experienced, whenever you buy any product in Amazon, you will receive some set of recommendations before you are going to pay the money. That is nothing but the recommendation engine, which Amazon will create for your user. So every user by default will have a recommendation engine, which Amazon will assign. So that particular user will receive recommendations from that particular recommendation system automatically. So this is going to happen only if the system is going to capture your real-time actions, which pages you visited, which products you selected. This kind of information they will capture. According to your interest, they will try to send you the recommendations to system. So this conventional data warehouse has been converted to big data warehouse, and slowly it converted to big data lake also. So big data lake here means a data warehouse with is nothing but historical data. When I say data lake, it is a combination of both. Data warehouse, like historical data plus current data also. Both will be available. And coming to traditional data warehouses, the challenges are very high. Infrastructure has a service, so we need to buy the enough infrastructure to maintain that, and limited storage capacity, because the storage also will be limited. High cost. Whenever I want to go and store huge amount of data, I should be ready for the high cost also. Limited processing capability, the process which is basically time consuming, and again, if you want to increase the processing speed, you need to buy additional infrastructure. No scalability. Scalability means adding additional infrastructure whenever it is required automatically. But there is no scalability available, and failover and replication also will not that much easy compared to other databases. And finally, data security. This is also very important. Whenever you store any data in database, you should have the security features also. Masking, data masking. Example, how can we mask the customer sensitive data? So the security features also should be available in the database. If you go to Oracle and all, you will have security, but at the same time, you also need to see how to mask your data, because we need to go and write our customized code also. But all these key challenges I can easily rectify using the cloud databases such as Snowflake. But big data also will sometimes help you to rectify all these challenges. But maintaining the big data or trying to convert a data warehousing technologist to big data engineer is also not easy. Because whenever people start experiencing this big data, they want to also hire some people who knows big data, or some companies also started like giving training to the data warehousing developers. They have started giving training to become a big data engineers, but not everybody will be interested to become a big data engineers who are working on ETL, because the learning curve will be very high. If you observe here, so many frameworks which you can see here in the big data side. These tools or frameworks are very popular in the early 2012, 13 and 14, this particular decade. People who wants to maintain big data, they should learn all these frameworks to maintain the enterprise level data lake or data warehouse, big data lake or big data warehouse. So challenges for data warehousing developer is they need to learn all these frameworks. If you don't learn, you can't survive. So many people started thinking to switch to this big data, but some people started getting afraid of learning this many. So as a big data engineer or data engineer, I should be ready to learn all this. That is what the fact in early 2012, 13 and 14. Or else you can't maintain the big data environment. Similar to that, every company also start experiencing challenges, because big data ecosystem is very, very fragile, and it will be keep on changing. Maintenance is hard, patching, upgrading is hard, even performance also requires manual intervention. Finding a technical resource also very, very difficult. Who knows these many frameworks? And we should also hire people who knows how to manage the Hadoop big data cluster also. And we can't reuse the people who already know this particular big data or conventional data warehouse to use here. So because everybody may not be interested also. Rare resource means high salary. These are all the challenges companies start experiencing. And every company start experiencing this particular challenges to maintain the big data environment. At the same time, every developer also start experiencing challenges to learn these many frameworks. So these challenges became the reasons why people started moving to the cloud databases. In that, Snowflake is one of the next generation of big data. Snowflake, why people are moving to Snowflake is the Snowflake is a cloud data base, but however, learning curve will be very, very easy compared to big data side. That is the reason every person who wants to migrate to Snowflake, they are very much interested, because learning curve will be very low compared to big data side. Only if you know SQL, you can start learning Snowflake very easily. And big data supports structured, semi-structured, and unstructured. Even Snowflake also supporting all this semi-structured, structured, and unstructured now. And live data streaming in big data side, we need to use Kafka. But in big data side, in Snowflake side, we can use even Kafka there also. Kafka connector will be available. So I can capture real-time transactions also. And product stability, if you see, big data ecosystem is, since it is keep on changing, the maintenance is not easy. But in case of Snowflake, everything is integrated with the tool, and you do not need to even go and action anything with respect to any challenges. And maintenance side, if you see, in big data side, you definitely need to go and work on some C++ nights in DevOps side. But in Snowflake, we do not need to worry, because the product maintenance will be done by Snowflake team, not you. Since it is a software as a service product, patching, upgrading, and provisioning are seamless. That will be taken care by Snowflake team in the background. And performance does not require any manual intervention for big data. And similar to the requires a manual intervention for big data, whereas Snowflake does not need, because everything is inbuilt. We do not need any manual intervention on the performance optimization. Snowflake itself will try to follow that. And data transformations. What is a transformation? Can someone answer if you know? We have a extract, transform, and load. What will happen in transformation? Who will tell? In general. Did anybody heard about ETL process? Extract, transform, and load? In that, what is meant by transformation. What we do as part of that? Any idea? A transformation is going to convert your data into a form that is ready for my analysis. We have like a joint transformation, filter transformation. We also have like unique transformation. We have many different transformations available to maintain your data, and where you will go and convert them into a form that is ready for my analysis. So in big data side, you will write some PySpark scripts to achieve that. But in Snowflake side, we do not need to use any particular scripts here. We can directly use tools available, graphical user interface tools available for this particular transformations like DBT, Matillion, Informatica, IACS, stream sets. Many different tools are already available. And supported side, which is important here. Big data can go to like according to the on-premise capacity and cloud capacity, we can go up to the maximum what they are providing. But in case of Snowflake side, we can go and worry about all these particular challenges. Snowflake will give the infinite, unlimited like uh, support and unlimited data we can store. And the resource availability also, big data side is not easy, very difficult to find out. But Snowflake side, we can easily train people and we can migrate them into Snowflake because a person with SQL knowledge can easily learn it. Even if you don't know SQL, that is okay. And coming to like salaries are extremely high for both, almost same. And use cases, if you see, most of the big data ecosystem will be used for building real-time systems, whereas Snowflake can be used for both real-time systems and batch systems also. So this is how Snowflake is becoming the next generation tool for big data. And apart from that, if you go and see the advantages of Snowflake over on-premise is like, just to summarize, it is a software as a service product. We can easily set up the free account within 2 minutes and we can start using it. And after you created your account and start building your environment, you need to also focus on mainly on scalability and availability and security. And also, once after you created the account, you can directly go and log in and create your own databases, tables, all this stuff. So data retrieval will be very faster compared to other databases. And pay as you go, flexible cost will be there, billing, and zero maintenance, no maintenance cost, and it comes with a cloud native advantages. And the data sharing is one of the features that will try to help us to share the data with others. And near zero downtime, almost no downtime. And time travel and fail safe, these two features also are very important features to restore your data which you accidentally deleted. So most of these particular tools are making Snowflake unique in the market. And coming to like at high level, which are the topmost reasons why people are choosing Snowflake is simplicity, which will help us to create the Snowflake account within 1 to 2 minutes. So simple, serverless, and plug and play. And I can scale up to any amount of data, any number of users, and any amount of workload also. That is called scalability. And elasticity, this is also important to understand. Every Snowflake SQL statement which you are running requires a warehouse to be running. Here warehouse represent that is a group of clusters that will try to provide the resources for your query to execute. So the size of the virtual warehouse in Snowflake will determine how fast the query will execute. So we have like warehouse sizes starting from x small to till 6x large. But here the size we can select of our choice, and this size sometimes will instantly will go and increase and decrease. That is called elasticity. Scalability is mainly looking for concurrent users, whereas elasticity will look for a single like particular environment where we can go and help us to find out the size. And size will differentiate here how fast the query will execute. And flexible cost, which is nothing but pay as you go, use and pay, no need to pay in advance. And finally, diversity is another feature where people are using they are diversified by storing data in one place and acting from multiple locations. And coming to Snowflake architecture wise, it follows a shared disk and shared nothing architecture combination. Normal traditional databases will follow shared disk architecture. So when you go and try to see whether the particular shared disk here, the shared disk will be automatically, whenever this is down, all this will be down. This is normal traditional databases like Oracle, SQL Server are following. So this is down, for example, all will be down, which is not correct. So that is the reason we got shared nothing architecture now in the market. So shared nothing architecture means we can go and try to create a machine with its own storage. So even one is down, other machines will be there to provide the data. So shared Snowflake will come up with a combined a shared data centralized architecture, which will help us to run your SQL statements in the Snowflake environment. Without SQL state a warehouse, we cannot run any SQL statement in Snowflake. Always remember that. I should have a warehouse, or also called as virtual warehouse, to be available. Without that, I can't run any SQL statement because that virtual warehouse will provide the CPU, resource, temporary storage, memory, everything to run your query. Why we need a CPU, temporary storage, and memory to run a query? Who will answer? Why we need a separate machine or group of machines to process your data? Because the virtual warehouse will provide the resources which required to run your query. At the same time, they will charge you. So the charges are very transparent. They will be added to your monthly billing. Once after you finished using this particular environment, then monthly wise you have to pay the bill where Snowflake will charge you, and that bill will be generated according to your consumption only. If you are using a bigger warehouse like with medium or X large, your charges will be more. If I am using a very basic level like X small size, then your charges will be almost very, very low. So the size of the virtual warehouse or warehouse will determine how fast your queries will execute in general. So this is majorly Snowflake architecture, and this is how you can understand shared disk architecture, which I was talking about. We see one particular disk storage is there, which is shared by multiple clusters here. So this is normal traditional databases will follow, like Oracle, SQL Server, and other databases. So if this is down, all will be down. And this is what the challenge every company was facing when before big data. Whenever we move to shared nothing architecture, every machine will have its own storage. Even one machine is down, other machine will help us to provide the data. So shared disk and shared nothing. So this is a shared disk architecture, shared nothing architecture, whereas shared disk is nothing but you will try to connect to one storage disk to receive the data. So these particular features are making Snowflake unique in the market. And coming to other features which Snowflake is offering are security and data protection, which I just was talking about, like how to secure your data by some authentication, user multi-factor authentication I can configure, and I can also go and integrate the particular communication with the TLS, and I can also integrate my Snowflake account with the enterprise level LDAP or SSO also. For that, people are using nowadays Okta. Okta is one of the tool for integrating your Snowflake environment with the enterprise level SSO or LDAP. And standard SQL support. Snowflake follows a ANSI SQL commands. So all the DDL, DML, DCL, every command, you can see the similar command how it is in the other databases. Here also the same. I can get views, stored procedures. I can simply use the same syntaxes for all the basic SQL commands. Connectivity, this is also important to understand. Whenever you want to process any data, you definitely need to go and use some connectors here to use this particular data and apply some transformations. So to apply some transformations, we need some source data. So Snowflake can act as a source database. So I can connect Snowflake with tools such as like Power BI or Tableau, or I can connect with the Python Snowflake connector. So this will try to allow you to manage Snowflake environment from their particular tool. And data sharing, another feature which companies are specifically interested to transfer their data in a secure manner without copying the data. So data sharing is very, very important feature which we need to understand to share your data with the other Snowflake accounts. And coming to like Snowflake architecture, Snowflake come up with 3-layer architecture. So 3-layer means the first topmost is called as service layer. Second one is blue color is called as compute layer. Third one is called as centralized storage layer. The first green layer is responsible for most of the authentication. Just 1 minute, guys. So the 3-layer architecture, the topmost layer is the service layer, which is so like responsible for authentication. Whenever you log in into Snowflake, you will connect to this layer only. And the security side, if you see, the security is basically like how you are going to provide that MFA, multi-factor authentication, and we are also providing some transactions management, and all this will happen with respect to the topmost layer. Whenever you create a Snowflake account and login, you will connect to this layer only. And second layer is responsible for the actual development. Any development activities you want to perform, this second layer is responsible for that. This layer is going to help you to run your SQL queries. In this layer, you will create your SQL statements and tables, everything here. And also, you will try to create your virtual warehouses also here. The virtual warehouse which I was talking about, which is also called as compute. A virtual warehouse means not like a data warehouse. So the virtual warehouse will help us to run your SQL queries. Without virtual warehouse, you cannot run any SQL query. And the centralized storage layer is basically will store your data. So this layer will be like going to help us to store in the cloud side. The cloud can be either AWS or Azure or GCP. So Snowflake, when you are trying to store the data, Snowflake will use one of the storage. So we have to decide which storage you want here to store. For example, if I create my account with AWS cloud, you will see Snowflake will store all your data in the S3 bucket, and all your compute will be maintained using the AWS EC2 instances. If I use Azure, my storage will be maintained using the blob storage in the Azure side. All your compute will be maintained using the Azure VM instances. So according to the cloud, Snowflake will maintain your data as well as your compute. So here compute means what? Whatever the resources required, like CPU, temporary storage, memory, all this will be provided by Snowflake according to the cloud you selected. Without that, you can't run any SQL query in Snowflake environment. And also, the Snowflake architecture, like cloud services layer, as I mentioned, which is responsible for maintaining the metadata, authentication, and also your query plan generation, SQL query plan generation. Most of the things will happen in the cloud services layer, the topmost layer, which is also called as Snowflake brain. And second one, query processing layer, also called as compute layer, where your actual development will happen. This is basically will be maintained by like Snowflake with the compute with a virtual warehouse, which is a group of clusters. A cluster, again, a group of machines. So whatever the CPU, memory, temporary storage, all these will be provided by the virtual warehouse whenever you run your SQL queries. So for all these resources which Snowflake provide, they will charge the customer to pay the money also. So you need to pay according to your consumption. Snowflake will never charge you a single extra penny for what you are not consuming. Whatever you are consuming, you need to go and pay for that only. So if you are not consuming or running any SQL queries, you do not need to pay anything. That is what Snowflake will going to charge. And coming to like the data storage layer, as I mentioned just now, your data will be maintained according to the cloud you selected, either AWS or Azure or GCP. These three clouds you can select. So your data will be maintained according to the cloud you selected. And also one more thing which you should understand, whatever the data Snowflake will store, it will automatically compress that. So compress and it will store. So if my data volume is high, once you copy the data into Snowflake environment, Snowflake will automatically compress it. That is the benefit with Snowflake. You do not need to even inform Snowflake to compress it. So the data storage layer is responsible for that. And how Snowflake is different from other cloud databases? We have Redshift and Snowflake. So Redshift is the cloud database in AWS side. But Redshift side, compute and storage will be combined. If you want to go and increase storage, you need to restart the Redshift cluster. Or if you want to increase the compute also, you have to restart the Redshift cluster, and both are combined, so the downtime will be there. But in Snowflake, that is totally separate. Even if you increase the storage or you increase the compute, both are independent. So you do not need to stop anything. And coming to to maintain any semi-structured data, Redshift side, I need to use another feature called Spectrum, which is costly. But in Snowflake, we can maintain that directly using Snowflake functions itself. Yeah, Chandra.
Hi, Sri. So in your previous slide, there was something written as a hybrid columnar. Can you please expose it? What is hybrid columnar?
Hybrid columnar. No, I didn't get you. Come
Yes.
again. What is your question?
Yeah. In your previous slide, previous slide, yeah, this one. So
columnar. So columnar oriented means normal traditional databases follow row oriented. Correct? No.
Yes.
Rows they will try to store the data, but in case of Snowflake, it will use a column oriented. It will create a group of micro partitions. Micro partition means here one file, and your data will be maintained as group of column families, not like row oriented. So it will focus on, for example, I have 10 rows. It will not go by row oriented. It always go by column oriented. So it will try to store the data in the form of columns. So columns will be related, not like row. That I'll explain you maybe once you go to the micro partitions. Okay?
Okay, sure.
Yeah. Because most of the databases in the market now, they are using column oriented only. So we'll understand about once you go to the column clustering and micro partitioning. There I'll clearly explain what is column oriented also. I'll show you with some example. Coming to like Teradata, also similar to this Teradata and Oracle also they are also going to have the same challenge because they also have some cloud, but the same challenge. They are also compute and storage are tightly coupled. And in Snowflake, again, they are separate. So whatever the challenges in other databases they are experiencing, all those challenges have been automatically resolved here in Snowflake with some additional features. Most of the maintenance is zero here. And pay as you go. Easily scale up and scale down. And process the data in the minutes, not in hours. So all this will happen automatically most of the times. Scaling also will be done automatically. So, but in Teradata and like Redshift and Oracle, we need to do the scaling also. Manually, I need to go and increase the scaling means I need to increase the server number of clusters. But here, Snowflake will automatically scale up and scale down. We do not need to even go and do that. So that will increase your processing speed also. And Teradata also having the same issues, and Oracle also will have the same kind of issues, and where Snowflake is becoming the solution for all the challenges that are experiencing in the other databases. And coming to like Snowflake architecture wise, if you see, most of the sources are coming from here. But one thing which you need to remember here is, for any data you want to load into Snowflake, you need an intermediate storage. This is important. Without this, you can't store into, or we can't store load into the Snowflake environment. So S3 bucket is for AWS if you are using, blob storage if you are using Azure side, and GCP, GCP like Google Cloud Storage if it is the GCP you are using. All these basically will be decided based on your selection of cloud while creating the Snowflake account. And most of the data will be loaded into Snowflake by using the intermediate storage S3. And these are all the different features that will help you to load the data into Snowflake, like internal stage, external stage, snow pipe, and external table. All these will help you to automate your data pipelines from different sources. And then we can store into the Snowflake environment. Later, this data will be used by the end users, consumers. But how to load this data, we will learn. How to go and use this particular internal stages, external stages, and the snow pipe. Most of the features will help you to automate the data loading. And how to create and how to use them, we will learn step by step. And come into like platform or environment side, this is another example of another project where you see Amazon S3 is the centralized storage, and you from S3 only you are loading into Snowflake, but to use the data from S3, we are loading data from different sources, and we are using Informatica as a tool here. And we are trying to load into S3. From S3, you need to enter Snowflake. As I mentioned, without a intermediate storage here, we can't load into Snowflake again. Whatever data you're loading in Snowflake, before loading, we are going to load into this particular S3 bucket as of now. And data storage is in S3, and ingestion is happening from Informatica and from different sources. And then finally, data analytics is happening with the majorly this particular tools, dashboard tools, where they will go and connect to this particular Snowflake environment, and they will try to pull, and they will try to build their own dashboards. So whatever the data these particular consumers are using, they are the end user. So the Snowflake data which are going to centralize should be the right data, because the end users are going to use it. So we need to create the automated data pipelines to load data from all these sources as per this particular example, and that will be happened by Informatica jobs here. They will try those jobs will pull the data from all these different sources and push into the S3 bucket as group of files. From S3 bucket, we can load the data into Snowflake directly. For that, we use, as I mentioned, the previous example, whatever you see, snow pipe and external stage, external tables, all this will help you to load data from this particular S3 bucket to Snowflake. So that we'll learn anyway. So one by one we'll learn. But these are all the example platforms, real-time platforms, where Snowflake data has been people getting migrated. And coming to like account setup. So whenever I want to go and use Snowflake, I definitely need to use a Snowflake account. How you use a Gmail account. Similar to that, I can create a Snowflake account also. The Snowflake account can be created directly by visiting Snowflake website, and there it will allow us to create a 30 days free account. So that 30 days account I can create, simply go into the Snowflake. Here. Snowflake free trial you can search, and it will allow us to create a 30 days account which you can create. So there is an option to create a 100 days account also, but I'll show you that later. But as of now, simply go and sign up snowflake.com page. You can get a free account by 30 days free trial, and you can give your details here, and where you can go and select any one region here, and you can mention any name here. And here, this is called Snowflake Edition. Snowflake Edition is going to help you to opt what kind of Snowflake features you want. We have standard, enterprise, business critical, and virtual cloud, private cloud. So virtual private cloud will not be available here. If at all you want to use it, you need to reach out Snowflake team, and Snowflake team can only help us. But all these three Snowflake editions I can select. Standard is the basic level. Enterprise is standard plus it will have some other additional features. And the business critical is another like a addition which will have enterprise features plus some additional features. So business critical is the like a common edition people use in specifically in banks, because they are worried about data protection, database failure, all these you want to maintain, then business critical edition is required. But most of the other companies may not worried about data protection and all, so they will go with enterprise level. So for our case, as of now, we go with the enterprise. We'll select and check this checkbox and click on one of this cloud. Which cloud you want to host Snowflake? I can select one cloud of my choice, either Azure or AWS or GCP. I will select AWS as of now and click on get started. So this will allow us. So skip. Then it is setting up. They will send an email to our account. Let us try to see. I would have received an email. So they will send an activation email which we need to click on. So you will see a activation email like this: activate your Snowflake account. So you need to click activate. Here you can enter your username, and you can give the password also. Once you press enter, this will move to the Snowflake Snowsite interface. It's very easily you can create very fast. So this is called Snowsite interface. You got $400 free credit. Snowflake will provide you and a 30 days trial. So you can use up to 30 days and $400 credit until it is completed. So you can start running your commands here. There you can go and start running your SQL commands directly here. So as I mentioned, we need a virtual warehouse required to run any SQL queries. For every new account, Snowflake will automatically create the warehouse here. This is automatically created. I can use this warehouse for running my SQL queries. As of now, these are the three default databases Snowflake will create for every account, new account. Even if you create, you will see these three accounts by default. And to get your own data, these are all databases. So every database will have some sample schemas here, and I can get my own database also. To create that, I need to use create database command. So when you see here, a database has been created, demo. So default, you will see two schemas, information schema and public schema. No tables as of now. I can get a table also here. So I'll try to refresh this. So what I do to point to this database, I need to use one more command called use demo. So demo public. Now I will go and create one table also. So I just created one table here. So a table got created. You can see here. So it is similar to our normal SQL commands. We can go and simply load the data using insert command. Under delete, I can use update. So I loaded one record. You can see one record has been inserted. So like that, I can insert a number of records, but this is not the practice people follow. We need to go and load the data by leveraging a process directly. We need to load like millions of records by from file into Snowflake table, or we need to go and create a process where we can load the data from S3 bucket to Snowflake table or blob storage to Snowflake table. These kind of process people follow in the production. So we learn anyway how to load the data from S3 bucket to Snowflake also, and how to migrate a MySQL database to Snowflake. These kind of use cases we learn in our particular training. But as of now, just to understand how to create a Snowflake account and how to load the data and a sample data, how to insert the data, and also we can update the data also. I can insert data, I can update, I can like delete, I can follow all the regular SQL commands here. If I have multiple rows, we can simply use the where class. So it will update, and if we go back and see, select the data, my salary might have changed to 20,000 now. So update command also will be similar to our answer SQL command. Delete also the same. I can delete from table name and where condition. So all these are quite common to answer SQL commands. And what you have to understand here is whenever I go with any data loading, Snowflake will require that particular cloud to be used here. If I am using AWS, I also always need to go with S3 bucket only. If I am using Azure side, I need to use the blob storage. If I am using GCP, I need to use Google Cloud Storage. But from the interface also I can load. For example, from this interface I can load the data also. There is a process. Go to databases and select which schema you want. I want in this schema, and I want to create some table. Click on create table from file, and I can browse where my file is available. Assume I want to create a table from the CSV data. So I go here and I have a CSV file available, employee file. So I'm going to give emp here, the name as employees, but this is coming from a file. I'm just trying to load. I give like emp underscore data is the name. Click on next. So it will try to identify what column names of the file which we just loaded, and these are the data types. So automatically this interface is trying, it will go and identify the column names of the file, and it will automatically like assign what data types corresponding, and simply click on load. It will load all the file rows. See, 1000 rows got loaded. If you go back and say query data, it will allow you to select, and you can see this. These are the top 10 rows from the file. So in total, this table contains now 1000 rows. I selected top 10 by selecting the data and limit 10. If you go back and simply say select star from table, you will see all the 1000 rows. In 1000 rows we selected top 10 only, you can see. So this is one way to load the data, but this interface is having a limitation of 250 MB size only. If I want to load more than that, I can't load from interface, but I can load any kind of file. So if you go and see, it will allow you to load not only CSV, I can even load JSON and Parquet, Avro and ORC also. So the Snowflake allows 6 file formats which we can load. CSV, JSON, Parquet, XML, Avro and ORC. These are the different file formats. To load this data, I definitely need to follow some different approach. So you can see here, these are all the file formats. So even the client may send any of these file formats. You should be ready to load any kind of file, whatever they will share you. So to load this data, if it is less than or equal to 250 MB, I can do this method. If it is not more than 250 MB, then I cannot do this method. For that only we have to use some internal stages and external stages concept that we are going to learn in the upcoming classes. That I hope till now everybody is clear, right? Any questions from anyone? No questions?
No, Srinivas, will go.
So what I'll do, I'll try to share the sample files. You try to apply them to the interface. And you can try loading this data. Maybe CSV file I'll share you. I'll share some comma separate values, tab separate values, and also I'll share you pipe separate values also. If possible, I'll share a JSON file also. You can try with this interface and try to load them and see. Even if you get errors, don't worry. You try them and try with interface, but you need to create a free account first. On how to create a free account, I already shared the document. I'll share today also once again. You can create a 30 days account or you can also create a 100 days account. You can go and start creating this particular account. Once after the account is ready, start loading this data, sample data. Try with interface first. Even if you face any errors, document them and let me know what issues you encountered. Because when you are loading any data into any table in Snowflake, and even in your project also, you'll get so many errors. But as of now, just try with whatever the files I'm going to share and load them and try to see if you are able to create some basic tables with this particular interface. And you can also create a sample tables also, how we created like create table also. I'll share some sample commands on how to create some tables and load the data. You can work on that also. Okay. Yes or no?
Yes.
For today, please try this. And tomorrow I'll try to show you how to like use this particular Snowflake interface, and also I'll try to explain what is Snowflake pricing. So Snowflake pricing is basically important to understand by every Snowflake developer because the cost optimization is very, very important. The Snowflake environment requires the understanding of cost also, how to reduce the cost. So every developer should have that knowledge. So everybody will be interested on how to every management interested in how the developer is going to reduce the cost and how to use efficiently the environment. So you should know how to reduce the cost also, and how Snowflake is going to charge the customer and how what is the different ways to reduce the cost, and in different ways we'll discuss in the next class. But today, please try to work on what files I'm going to share. Okay? Yes or no?
Yeah.
Sure.
So I'll
Thank you,
share the
Steve.
files. I'll share the files in the Google Drive, and you will get the files from there.
Okay. Steve,
Mm.
one question I have.
Mm.
Will you be sharing any study material for
Yes,
Snowflake
you will get
certification?
all the materials, assignments, hands-on scripts, and recording.
Okay.
Everything will receive.
And those are aligned with the Snowflake certification.
Correct.
Right, Steve?
Correct.
Okay.
Not
Okay.
only Snow Pro, it is aligned with Snowflake Advanced Data Engineering Certification also, both.
Okay.
If any questions you have, you can ask me anytime. Okay, but I request you to share your email. That will be better because to share the Google Drive access, I need your email also. You can ping because I don't have your number because you came through, I think, IGM Guru, right?
Yes, you are right.
Yeah. Let me share your email. Okay, I will note down your email. I'll share you this particular today's class materials and recording and everything.
Thank you so much.
And any other questions from anyone? Kirti, Naveen,
No, sir.
Harsha,
No, sir, no.
are you good?
Yes.
Suhasini, how
Yeah,
old
yeah,
you?
no questions from me.
Okay, Suhasini. Huh? So, because Suhasini also can share your email also.
Yeah, yeah, I'll
Yeah, please share your email. I'll share the recording and other materials and other stuff so that you can also go through once. Okay? And we'll connect tomorrow at the same time and we'll try to learn about Snowflake pricing. Okay?
Okay, sure.
Okay, then. Chalo, yeah. Thank you.
That's all. Bye.
Bye.
Thank you.
Thank you.